Thank you, Nikki. So I'm Judith. I'm from Montreal, Canada, and I want to proceed with a land acknowledgement. So I respectfully recognize and acknowledge the relationship that the First Nations, Inuit, and Métis people across Canada have with the land that all Canadians live on and enjoy. I recognize human rights of people who have suffered from systemic racism and discrimination in Canada. I seek to provide a welcoming, engaging, and safe community for everyone. Welcome everybody to this BINA AIMM presentation. Katrina.
So today we have the privilege of hearing the presentation from Julio Mateos Langerac, who is working in France, and he will present a project that is leading, a software development project that is leading to facilitate the management of quality control results. So quality control, the results of quality control that is done on instruments, for example, so that it can be recorded in Homero and can be associated with images that are residing in Homero, so that when you are in Homero, you know that your images were acquired in context of that your instrument was at a certain level of performance, and you can make decisions regarding accordingly. So Julio, please take the floor.
Oh, can you see my screen?
Yes.
Okay, great. Thanks everyone and the organizers for inviting me here and giving me the opportunity to show our work. So as Katrina said, I'm going to talk about Homero Metrics, which is a tool based on Homero to manage metrology data for the microscopes. So I'd like to start with, though this might not be very pertinent in this for this audience, but I'd like to start by saying why we want to make quality control on the microscopes, and that's because they are very sophisticated and precise measurement tools, and we need to keep them to a good condition. And I think this quote by Bertrand Russell says essentially everything. Every careful measurement in science is always given with a probable error, and every observer admits that he's likely wrong and knows about how much wrong he's likely to be. So it's not only about to know how good we are, but it's not only whether good or not, but know what is our margin of error. So why do we measure microscope performance condition? Is to ensure that that we detect the degradation of performance as soon as possible, so we can react to it and fix the problem. Provide evidence also in the dialogue with the microscope manufacturers. So sometimes we have a problem and it's more or less difficult to convince the microscope manufacturer that there is a problem, and we need elements to have this dialogue. Also, we need those measurements to be able to calibrate the hardware. And also some of these measurements might be used for further image analysis, like PSS for the convolution, so on and so forth. So when do we measure quality on the microscope? We do that mainly through its own lifetime, but importantly in the very beginning of the installation, so that we know that we can accept that microscope as it was intended to be used, and then on a regular basis during the service life of the microscope. But in different moments of this, either periodically when there's doubt about the performance of the microscope, and when there is some change on the microscope, we move it to another place, we change the air conditioning or whatever. So Omero Metrics is a tool that we have built after the experience of metrology. And so Metrology QC is an ImageJ plugin that we use here to monitor microscope performance, and we are based on that to develop this. So we use Omero. I'm going into that detail for the data management, and Omero Web as for its capacities to provide a nice interface, being user friendly. But this tool is also for providing, in the same way that a paper has a digital identifier and the researcher has an identifier, and those data are stored in we call in France entrepôt, I don't know, data repositories like the image archive. One of the things that we want is that through storing the metrology data next to the image data on a paper, in the same way that, like for example, Micrometa app is going to store microscope configuration. Also, the quality control should eventually link to the core facility stuff, and in that way provide a way to recognize the work of core facility staff as parts of the research process and all the hard work that we do in this endeavor. So Omero Metrics is built. I don't know if you can see my mouse. And it's built on a data schema that we call microscope metric schema. And there is another tool which is called Omero microscope metrics. That other tool is containing, so to say, all the algorithms that do the image analysis. And those are used by a third tool, which is called Omero Metrics itself, which is a web app that is used in Omero Web for seeing what I will show you later. That has been done with the financing of Franceberry Imaging, and that has been done by Umu. And she's been doing a great job in developing this tool, and with the help of the AIMM community. It's all based on Python, and our focus is to provide easy of use for it. We want to build something that's very easy and also fair. And for that, we use Omero, of course, and we use LinkML as the main tool for building the schema. How does it work? So I'm going to run through a demo, so we'll show you this. But essentially, we do a first-time configuration of the analysis. Then we import the images into Omero, the way you probably all know, in a well-defined structure. I'll talk about that later. And then we can run the analysis that will run on the server. And then we can visualize the results in the dashboard. So core concepts. One of the core concepts that we want to promote is that we embrace in the ISA model. That means that data is going to be grouped under the concept of an investigation, study, and assay. And that relates to an investigation. It's a group in Omero, and that relates to an instrument, a microscope. So a group in Omero is a microscope. That serves essentially the purpose of grouping all the data together, but also as Omero uses, as we use Omero's permissions model, we use that to manage the permissions to access the data, because most of the time, every microscope will have a number of core facility managers that are responsible for it, so those can modify the data, and so other core facility members might want to see the data, but they should not be allowed to change the data. And eventually data can be made public and shared with the users of the facility. That's something that we have in sight for the future. Then the study is what corresponds to a project in Omero. And that corresponds to a type of analysis, like an homogeneous analysis that we follow over time. Let's say the field homogeneity with the 20x objective, or the PSFs we use in the 60x objective, so on and so forth. And what is an assay, a data set in Omero, is what corresponds to one measurement that we take in time, one maintenance session. Okay, that's the key. That's one point in time. And I think I'm going directly to demo here. I can show you. So Omero. Okay. No. Oh, easy password. Sorry. Give me 1 second. Okay. Doesn't want to connect. Oh yeah, there's a typo here. So we're now in Omero. Can you see the text big enough? You have to tell me if I have to zoom in the window or not, so that you get an idea of the screen. So that would be your normal group. Let's go to one microscope. So here you see we have the 2 microscopes and the different core facility members that can see the data on the microscope. So if I select this microscope, it's a very simple project. I have, for example, let's go all members, because I have another data set there. So if I select this data set, so that's, for example, field illumination 60x. And I have here one data set with some field homogeneity images, another data set, 2 points in time. That's very simple for demo purposes. Okay. And there is nothing in there. Okay, I just imported my images. So now if I select the project, I can go here and go to metrics view. So if I select it, because this project was just created and I imported the images, there's nothing. So we have to configure it first. That's a one-time operation. So we have to tell it what type of sample it is. And I'm going to say this is a fluorescence homogeneous thick field, a chroma slide, right? Select it. And then I have to configure some information that I want to give to this project. Okay, so what do you write here? It's could be, it's a bit of a repetition of the data sets of the project name. Okay. Can give a description. Demo. Protocol we should provide here, that's a mandatory field. So we have the possibility of making things required. One thing I have to mention here is that all of this information, this form, is based on the schema. So if a field, those fields are provided by the schema. If I make a field in the schema, what we call a slot, mandatory, it will appear as mandatory here. And this is defined to be a URL to, for example, protocols.io, blah, blah, blah. Okay, we can set up a manufacturer. So So this is, as you can see here, this is a sample configuration. It's very simplistic. That's it's still a bit in development phase, but anything that we add in the schema, as I said, will appear here as an input. Okay, so next. And for every analysis, there are some input parameters, okay, analysis parameters, as I said here. And it provides some defaults, right, which are normally chosen to be working, but you can manipulate them if your analysis are not working. There is a bit depth here, which we provide. That's something that we have to provide most of the time. In the case there are cameras that save the data in 16-bit, but they actually have a 12-bit bit depth. So that's why it's something I have to provide. Otherwise, if we don't provide anything, it would assume it's the data file from data format. Okay, go next. We have the opportunity now here to review the parameters, and we can set the configuration. Okay, now it's all good. Okay, now we can go back to the settings, change them, etc. Now I select the data set, and now the data set has not been analyzed yet. And we can, so this is the information that comes from the configuration. Okay, for the moment, this is not modifiable because we want to keep things standardized, okay, in such a way that the user, once the configuration has been done, he's not able to change parameters of the analysis. That's something that we're not sure is going to work in practice, but we will see. So we say next. There are 3 images here. We can tell it, by default, it's going to select all images. We can put a comment here, something like, for example, I just like the fiber, and then the parameters are there, and say next. I can review the information and send run analysis. So now microscope metrics is running in the background in the server to analyze the images, and also good, done. So if I can select an image now, and I'm in this metrics view here, I get a view of the detail of the analysis, like an image where some ROIs, where measurements were taken, the lines of the profiles, the center of intensity, and so forth. We have different color schemas. I mean, these are just things that we can enable. We can zoom in, it's all interactive. We can choose the channel. This image has only the DAPI channel, but if I select this image, which has 2 channels, you get 2 channels. So I have to say, these homogeneity images look very nice because it's all simulated data. Okay, we work with simulated data. Okay, we can just, okay, so we have a number of options here for visualizing. Now, when I select the data set, there is a process of compilation of the information from all images. Okay. So now we have here the possibility to check all channels, right? So it's a combination of all the images that are there. And these are, so to say, key, what we call key measurements that are available, that we measure. So what is maximum intensity, center region intensity fraction, etc., etc., and the profiles of every channel. Now, when I select the project, I have a time course of the measurements. Now, there's only one point because I analyze one image, one data set. If I come here and analyze this guy again, tack, I go here. Now there will be 2 time points. Okay. So again, here at the project level, like the the study level, we have always a time course of the measurements. We can choose which measurement we want to see. We can choose a date range. We can also put thresholds, and importantly, we can delete everything if we want. We can download. I'll go into that later, maybe. And that's how essentially it works. Now, if I select, for example, this PSF beads dataset, which has 12, they said that would take some more time to load. There we are. So there is a time course. Of course, this doesn't make any sense. It's all simulated data, so, but you get the point. Now you see this line. I don't know if you see there, this upper threshold. So we can define also thresholds, okay? So in this case, I defined, for example, this threshold. And I can update the threshold. And if I should reload this, so those are thresholds which are, how to say, fixed, hand fixed, so to say. We want to implement in the future something a bit smarter, like some functions that are going to detect whether some measurement is increasingly rapidly and it's an outlier of measurements, things like that. And in the same way, if I select the data set, I get a view of the key measurements. I mean, here we have some ideas of what we want to do here for averaging information coming from different images. So, and if we take the PSF images, we can see the beads. If I select the bead, we get intensity profile here. Again, simulated data is very nice because it gives you also perfect PSFs. This one has been discarded because it's too intense, so probably the multiple beads. Can select the channel here, and so on and so forth. Okay, so that's about it. So now there's one more thing. If you go up to the group level here, there's another visualization of what we call a microscope health dashboard. We should compile the global health of a microscope. So this is just a placeholder. There is no information because we don't know quite yet how to do that now. Do we get the last point in time? Do we show alerts? Do we show a health graph? There are different ways to do those things, and we're not really sure how to plot the global health of a microscope. That's probably one of the things that we want to do next. So then that's about it. And yeah, what I want to show, for example, is the option to download the measurements. Now you can download in YAML. That would be probably you cannot see. Maybe I would have to share this. Let me share this other window. Okay. So this is a YAML file which follows the LinkML definition of the measurements. Okay, that file contains essentially everything that we have measured, like general information about the so to say the microscope, all the information of the microscope, input data, output data, all the ROIs, and for example, it links to the image the input images in some way, like we can say this input parameters. Where are you now? Yeah, for example, data reference, that's the input image. We have the Omero host, which is local host, not very interesting, and the port, and it's an image, and the image ID is this one. So this is a reference to the Omero image, right? Okay. So, oh, I'm not sharing anymore. So that's, I don't think I have a slide about, yeah, the attribution. So that's the people that's been involved. It's Umu she's been doing all the work on the web, and I've been working on the schema and the analysis routines. Guillaume Gay is involved in the deployment of the solution in France. We are setting up a demo server. Cedric Matthews is he's in charge of the strategic view at the FBI level. He's in charge of the mission of core facility integration. And then we have a work group of people that has been helping with the definition of the specs and they're going to test the software now, in short. So the documentation can be found there. No, not yet. And the last, so of course it's all open source. And some references are here. Okay. So I think I'm done. I don't know if you have questions or.
Thank you so much. This was amazing.
This is, yeah. I'm gonna let the floor to people who have questions, and if not, first of all, I need to congratulate you. This is a fantastic tool, and I'm very eager to try it. So I'm not seeing hands up, but here's my first question. How do we try it? Do we contact you?
Yeah. So do you? So now we have a demo server that we are going to put a few people that were in the definition that they want that they tried to break it. So that's step one, and we want to try this in two steps. We want to first try what is the web app, the interface that doesn't break, that's reliable, and then there's the image analysis part. So we have been working so far with how do you say, with simulated data. So we generate the data automatically, and that's for development purposes, that's very convenient because you can simulate every abnormality. Let's say you want to say you artificially create an image with bits that are all next to the edge, okay, and the software has to detect them all on the edge because you know upfront what you have to detect. Now we are setting up now the infrastructure to do some automated testing on real images from users. Because I'm afraid that if we open it, a lot of people is going to start to use it, and for one reason or another, the images are not well analyzed. Okay, I mean, a field homogeneity image will work fine always, right? But detecting bits can be tricky because the tool is, I think, quite strict in the quality needs for the bits. Okay, so we want to make a good fitting, and so you have to take quite large stack, and maybe people is going to start load images which are not big, thick enough, so to say, and then it's going to fail, and I'm sort of afraid that people are going to start to get the font being a bad experience because it doesn't work with images. So we want to try that with a set of images that we trust that are good, and tweak that. So we need to do that. So then we have the two ends. The graphic user interface is working well, and the background image analysis is working fine. And at that moment, I think it would be fine to let people use it. You can use it today. Okay, it's open source. It's there. You can install it. So that's one thing. And there are some technical things that we have to solve in the sense of, okay, I define the schema according to so what's going to be the path for standardizing the schema? Like we have to go, for example, for field homogeneity. I would like to go to the work group. I don't know the work group numbers. Three. Working with field homogeneity and say, okay, we're measuring this. Those are the things we're measuring. You probably want to rename some of them. You want to tell me, oh, this is not measured, or this should be measured. Thing. And then we change and then we establish a schema, because if we change the schema once all the data is analyzed, I mean, there is a simple way, which is, okay, we change the schema, we reanalyze everything, right? Are we going to get surprises? I don't know. And the same thing for every analysis. And then we have now field homogeneity, which was the easiest analysis. And we have PSS, which we think is probably the most difficult analysis. And we have to cover all the other analysis that are in between, right?
So you are aligning with Quarep for sure.
I mean, for the moment, I have not been doing it because of time pressure. Okay, Umu was with us for 1 year.
No.
We had to get this thing running, and there is a schema. We learned how to use the schema, the link mail, and now we say, okay, we know how it works. The web app, we know how it works. We know how to integrate it with Omero. We know all those things now. In principle, things should be much easier to integrate now. We are asking for financing because if I have to do this alone, it's going to go very slow. And so we are asking FBI for more money, for funding. And we hope to get the funding. And
so in that regard, is there something we can do to help being successful in your funding?
Yeah,
because this
talk about it.
Well,
so that was, I think, that's something I think was helpful to get the first financing. Is we got a letter from Quarep saying, with how they say, support letter, and I think that was very positive. So from the Quarep side, it would be great if you guys in America, I mean North America, would write something and say, okay, this is cool, we want that it's developed, and Quarep also writes that those are all things that are helping to get the funding. Yeah.
So you can count on us for sure.
Yeah.
So I see some questions in the chat. I can ask them, or if you want to ask them, Steve or Will, it's up to you.
Yeah. So there's this question of how to install Omero on my Omero server. Okay. What metrics are available? Okay. So how to install it? For the moment, installation is a bit is not yet a pip install Omero server. It would be, but that's something that I want to do soon. Is in the very same way that you install Omero Figure, for example. There are some tweaks that you do into the configurations because we use some tools which are not, which require some extra packages, and so we have the scripts. If you want to try it, you can run. It's in Git. I'll post the Git address. You can just run. It's all written in the README, but you can do a Docker compose, and it will run the PostgreSQL, the Omero server, and the Omero web in your computer. And there is a script that would to generate the so to say the fake data to play with, and you can run it on your computer. And which analysis are available for the moment? Field homogeneity and PSFs. And we want to do how to say chromatic aberration, chromatic correction,
co-registration,
co-registration,
yeah.
And those are next steps, and stage repositioning accuracy, because those are relatively easy to do, and the algorithms are already there in the PSF, so it should be easy to do.
But are you integrating the recently modified metrology QC that was modified last fall? Because for co-registration there was an issue.
Yeah, I think so. So Julian Co is developing metrology.
That's right.
It works one floor above from me. So
okay, so you
we talk with him. We know.
Excellent.
I heard. Yeah. We're and I want him to get to touch Python now.
Excellent.
He doesn't have a lot of time though.
Katrina, maybe.
No. There is Will first. How are the settings, data, and analysis results stored?
So those are stored. I mean, I can show you if I share the screen, because that's a critical point. I could share this. So if we get the data set, so there is a tracing of which analysis was run at which time as a key value pair, but that's just so to say. Okay, let's go here. They are as attachments. So there is one source of truth, which is this YAML file. And that YAML file contains everything. On top of this, we sort of say duplicate data as ROIs in Omero. So if I go to this image and I open it, it's going to be ROIs for the bit positions. And the whoops, what do I do here? And they are the dataset level. And there are tables for Omero tables for what is this bit properties, essentially all the bits, so that other users can use them. But those are duplicates of the information stored in the YAML. And in the project level, so with this attachment is this attachment is linked files. We link them also to the dataset and to the project. So these are duplicates of the tables linked to the thing. So essentially, is YAML files and tables and ROIs. And when we click the delete data, we delete all of those. Right?
Yep.
I don't know if that's
that's great.
Is that we have to discuss about this is a good way to do things. I mean, we find limitations on this in terms of performance, but we don't want to make things more complex using another method. And also, we're wondering to what extent we're going to hit performance limits, because to be honest, on the lifetime of a microscope, how many data sets are we going to have? I don't think we're going to have, so to say, big data. But
it's not so big, but I can tell you I have one particular microscope and I've been collecting measurements on it for 14 years. But it doesn't amount for a really big data set. It's still handleable. But the
Yeah.
question I have for you though is that at one point when the data set to be analyzed are really becoming larger and larger, is there a way to send the analysis to a computing clusters, or it has to be done on the same server where Omero resides, the instance resides?
Yeah, we consider this possibility. We don't know to what extent, if a lot of people started to make analysis on the web server. So there's some functions that are doing the analysis, and that's limited to one call or so. We can deploy those easily to some processor somewhere else if we hit that. So we thought about that. The other thing that we thought about, so when I'm talking about performance, is also, you saw that when I loaded the PSFs on 12 data sets, it took, I don't know, 30 seconds. Or is that acceptable? Because it has to load every single file. So we wanted to put everything in a single table. And that would work fine. That would be super fast. I mean, fast enough. The problem with that is that whenever we delete a data set, the software has to go find that table, delete those rows, and so forth. And that becomes a bit more problematic. The ideal solution would be to put another Postgres database. I don't know what Will thinks about that, but that implies more complexity on things. I don't know. The advantage of having YAML files is that when you want to export them, they're already there. So, yeah.
I have I think there is. So Alexandra had as a question, but it was answered by Michele. So I will ask my question. So one thing that I like your the use of your ISA structure. Instrument group. Instrument is the group. The assay type is the project, and the individual measurement is the data set. Now, this is all linking to the instrument. How do you envision linking to the images that were acquired? So how does the user, so this is, this would be done by the core facility. Let's say so you guys have a FBI, France Bioimaging nationwide installation of Omero. So you'll have all the instruments, I guess, that are covered.
Per node, yeah.
Yeah. Okay, and then okay, but then people will use it to be able to do their Omero, whatever, for their own data. And how do you envision linking, making sure that there is a link between the data that is acquired using that instrument and the calibration results pertaining to that instrument?
So Omero does not provide, no, I'm lying. Omero provides something like will correct me, provides something like a serial number for the microscope, but that metadata is not filled in by everyone, so we cannot guarantee that. So what we thought is, like, if I can share quickly the screen again.
So just can I interrupt you? Would you mean the serial number for the microscope? I mean, as a project, you mean?
No, so whenever you have an Omero image, when you have an Omero image, in the OME there's an ID, instrument ID.
Instrument ID. Yeah.
No, but that is in the metadata of the image.
Yes.
Of the source image.
Yeah.
But it's not filled in by Omero bioformats is not extracting from memory, so it's not a reliable source. So what we thought about doing is, if we select an image or a dataset, I think. Okay, we don't see it here. But let's say if I go to the regular images. No, it's not there.
But these are images that you used for the calibration. These are not.
Yeah, sure. Yeah. But if you would go to the, let's say, just go to your normal images.
Exactly.
Let's say we are out of metrics. That's my normal images. I create a new data set, and I think that has to be on the data set level. What we want to add, and we have some version where we have implemented this, a fourth tab here. Okay. If you click on that fourth tab, you're going to get a menu where you can choose the microscope from a list of. That's the easy way to the easiest way that we can find. The user is going to decide either on the dataset level, on the project level, the microscope that he used. And that brings me also into what are the future plans. Okay, so there are two things that we want to do on the longer term. Is that once our infrastructure is set in place, that one of the things that we want to do is it's a one-button click export of a certain group investigation to bioimage archive. If the users have marked to which microscope, with which microscope those images were taken, it should go and grasp those metadata and attach them to the files. How to do that, we don't know yet. There's a lot of work by the community in trying to how to establish an arrow crate and all that. So we're just waiting for people to tell us how to do that. So that's one thing. Another thing that we want to do, and that's on the longer term, is start to use to analyze the images of the users. Say, whenever I select a microscope type, I say, oh, I'm going to run some blind PSF extraction, something like that, and I'm going to measure some metrics on image quality on that real image, user image. Those measurements, we want to implement some kind of machine learning in order to correlate those user data with the data of the metrology in such a way that now we can start to learn how to predict when there is a problem in the microscope before we do the maintenance of the microscope.
Okay, so from the images, extract some level of quality from the images. Say, oh, this image is not good enough. The instrument has to be calibrated. Things like that.
Exactly, things like that. So provide, because it can be the sample, right? You can say if a single user is getting bad images, we can tell the user, oh, there might be something wrong with your images. Okay, just check it. But also, it's going to, if the images of every user using the microscope have a problem of a similar time, I mean, that machine learning is going to provide us all that.
That might be the instrument, obviously.
Exactly. And then we can say, oh, we have to go and check the microscope. Yeah.
Okay. That sounds great. Okay. Let's see. Oh, so you, if nobody else has a question, Ian, do you want to have a question because you turn on your video?
No. Sorry, my video. I just arrived. I was hoping to come earlier, but I was involved in other things. Because I was really hoping to hear Julio's talk.
Okay, you just arrived. Okay. So if you couldn't hear it, you can listen to it. It was, I mean, really worth hearing. So one thing that I didn't quite understand when you started the demo is it looked like all of the GUI is under basically the option to see data or to see so there is this menu on the side. So how do you launch the actual
So you normally in this view
signals. You go there and basically launch
and then you go here and say
metrics view. And then in the metrics view, then that's how you can launch everything. Okay.
Yeah. So we have also this plugin which we're experimenting with, this other view that opens a new window, right?
Yeah.
But you see it's completely experimental. There's nothing.
Okay.
I don't know what's in here, but this is a view that we want to explore eventually for sharing data with users. One of the things that some people is asking for, but not everyone, is that the metrology data are shared with the users, right?
Mm-hmm.
Like and say as a kind of as in such a way that users can see, oh, that microscope is good and I can use it, or yeah, don't know. That's something that we want to say that we want to do eventually at some point. At least provide a user the core facility to say, oh, we're going to put a bookmark in our browser or in the desktop of the computer where you can click and open a website where you can see what's the current status of the microscope, something like that.
Mm-hmm. Okay.
Yeah.
So this actually brings up another question. So basically, you're saying that users don't have access to the instruments view.
If the Omero group of the microscope is public, they will have. So we follow Omero's.
So it's a choice of the
permissions.
individual site to make it viewable or not.
Yeah, if they add the public user to that, or they use a particular user to that microscope, they can always check it. But that's all completely managed by Omero.
Yeah. But your idea is that they wouldn't have full access. It's only
not my idea, but
I mean,
so we
not
want to
your
provide
personal, the vision.
No, I think we have to share metrology data with the users, but that's something that you have to be cautious with, because you don't want to provide eventually raw resolution data, because then they're going to say, oh, that microscope is worse than the other one. I'm going to use the other one. And eventually there are other good reasons for that microscope to have lower resolution measurements. See, because it has more sensitivity, or because it's I don't know.
Yeah, no, there are many considerations too.
Many considerations. And do you want to simplify that and put just a green light or a red light, or?
Yeah. So I think these are decisions that have to be made locally. Different groups.
But we want that the tool provides a possibility to do it if you want, if you so wish to.
Yeah.
All right, this is amazing, Julio. I'm very excited, and I will certainly give it a try and get back to you.
So once we try it locally here, I will come back to people and say, okay, now we. Right.
Super. Okay, so we're almost to the end. First, again, thank you so much, Julio, for this presentation. Thank you to all of us who participated. If there are, I'm not seeing any more questions. So how do we get involved in Quarep? Quarep.org is your first stop, Alexander. And yes, thank you, Katrina. And then for now, we're gonna say thank you very much. We look forward to seeing all of you in the next BINA AIMM meeting, whether it's Pacific time or America time. And feel free to join BINA and Quarep. We're always looking for passionate people about open, reproducible, and fair science.
Bye-bye.
Bye-bye, everybody. Thank you again.
Bye. Thank you.
Bye-bye.
Thank you again. Bye.
Bye-bye.